In Module 2, you learned everything that you needed to know about series circuits. In Module 3, you will learn Ohm's Law as it applies to parallel circuits. A parallel circuit has more than one path for current to flow. If one component burns out, all the other components are still on. This is important. This is why if one light burns out in your house, all the others are still on. It's because it's wired in parallel. Voltage is the same everywhere in a parallel circuit. This is also important because we have devices, television sets, appliances, radios, drills, tools, everything else that plugs in has to have an appropriate voltage. We can't have 40 volts in one place, 120 in another. We have to have it all the same. This is a typical parallel circuit. Again, that has multiple paths for the current to flow. If this 120 ohm resistor were to burn out, this 40 ohm and the 60 ohm resistors would still be working fine. This is the rules for parallel circuits. And a voltage is the same everywhere in a parallel circuit. The total voltage is the same at the drop at E1, the drop at E2, and the drop at E3. Current is the sum of all the currents. So if we add up I1 plus I2 plus I3 currents, it will give us the total current. Resistance is the reciprocal of the sum of the reciprocals. This is a formula for it. It looks intimidating, but I'm going to show you how easy it is to use this formula. And then finally, power, just like a series circuit, is the sum of all the powers. P1 plus P2 plus P3 equals PT, total. Here we have 40 ohm resistor, 60 ohm resistor, and 120 ohm of resistance. And we're going to get 20 ohms because this is in a parallel circuit. Just remember this right now, that the total resistance in a parallel circuit must always be less than the lowest value resistor you have in the circuit. This 40 ohms is less than 60, which is less than 120. This 20 ohms must be less than that 40. If you don't get something less, go back to your calculator because you made a mistake. Here's that formula, and it gives us 20 ohms of resistance. Looking at the formula again, this is 1 over 40 plus 1 over 60 plus 1 over 120. So now we're going to look at just the reciprocals down here, not the reciprocal of the sum of the reciprocals, just the sum of the reciprocals. 1/40th plus 1/60th plus 1/120th. I can see right away that 120 is a common denominator because 40 will divide into 120 and 60 will divide into 120. 40 divides into 120 3 times, so I'm going to multiply 1 times 3. 60 divides into 120 2 times, so I'm going to multiply 1 times 2. And 120 divides into 120 1 time, so I have 1 times 1. Now I'm going to carry this over. 1 times 3 is 3. I have a plus sign, so I'm going to put a plus. I have 1 times 2 is 2. I have a plus sign, so I'm going to put a 2. And then I have 1 times 1 is 1. 3 plus 2 plus 1 equals 6 over 120. So this is 1 over 6 over 120. But whenever we're dividing a fraction into another number, it's the same as multiplying by its reciprocal. So I just have to go 120 over 6 and multiply it by 1, since 1 is not going to change any value. This 1 up here, I can disregard and just know that when I sum up these reciprocals, I'm going to flip the answer, and that's going to give me my answer. So 120 divided by 6 equals 20 ohms. If you're having trouble with this, go back to my series on fractions and proportions, and you'll learn how to add and subtract fractions. It is very important if you're in the electrical trades that you know how to use fractions, or actually any trade. Here we have 120 volts. It's the same everywhere. Here's that 120 volt resistor, 60 ohm resistor, and 40 ohm resistor. We have, excuse me, 20 ohms of resistance total. We want to find I. And here's the formula wheels. If you need to, stop the video here, write these formulas down in a scrap piece of paper so that you can see it. It's voltage divided by current gives me the resistance. Voltage divided by resistance gives me the current. And I, current times the resistance, will give us the voltage. Power is power divided by E equals I. Power divided by I equals E, and I times E equals P. You have 3 resistors in parallel fed from a 120 volt supply. What is the total resistance, voltage, and power? What is the power, voltage, and amps for the resistors R1, R2, and R3? Here we have 1200 ohms, 600 ohms, and 400 ohms, and we need to find our total resistance. We also know that this is a parallel circuit, so our voltage is going to be the same everywhere. We can put that in 120, 120, 120. These rules help us calculate things in this matrix. We have E divided by R equals I. 120 divided by 400 equals 0.3. 120 divided by 600 equals 0.2. 120 divided by 1200 equals 0.1. Amperage is the sum of all the amperages, so 0.1, 0.2, 0.3 is going to give us this value. We just have to add it up, and it is 0.6. 0.6 times 120 divided by 0.6 equals 200 ohms. We could have also used this Ohm's Law formula up here, and we would have gotten the same value, but this is kind of easy for people who are afraid of this calculation, but again, it is not difficult. Here, I times E, 120 times 0.6 equals 72 watts. 120 times 0.3 equals 36 watts. 120 times 0.2 equals 24 watts. And 120 times 0.1 equals 12 watts. 12 watts plus 24 watts plus 36 watts equals 72 watts. This concludes the instructional portion of this module. In Module 4, you will learn how to calculate the values for a combination series parallel circuits. This gets a little bit more involved once we get into Module 3, but you'll find that if you understand Modules 1, 2, and 3, Module 4 will not be that much difficult. Be sure to click on the link below to take the online quiz. If you're hazy about any of this stuff, go back and review this video as many times as you need to, stopping it, making notes as you go, and also doing practice problems.